So the reason I said that you had additional work for homework is because when I talked to a bunch of people about the concepts that we learned last week, and I asked some of you guys to check in, and the ones that did, I greatly appreciate it. People expressed that they had some difficulty with the SSA, which is our ambiguous case. So I wanted to make sure that we went over the ambiguous case one more time. So if we take a look at this, if I want to go over that ambiguous case one more time, I need to look at what I'm given. The only time you're going to have the ambiguous case is when you have SSA. And if you're having difficulty determining whether you actually have the SSA case, draw the triangle. So say I drew a triangle and I had, say, A, B, C. Label the parts. Well, I'm given A, and I'm given A, the length of A and the length of B. Well, A is across from A always, B is across from B, and C is across from C. If I highlight this and I say, okay, well, let me look, I'm giving A, B, and then angle A. You'll see that A is not included between A, side length A, and side length B. Therefore, we have our ambiguous case, SSA. So now what we need to do is figure out how to figure this out. Now, we were also told that you could have possibly one case or two cases. So we need to really think about this. Well, if I'm giving little a and I'm giving angle A, I can use my law of sines by setting up 6.92 over sine of 25.2 degrees. All right. Now, look at the other information I'm given. I'm given little b. So I'm given side length B. Well, I can put that 4.82 over the sine of angle B. And now I can use this information to solve for angle B. So if I take a look, I can cross multiply. I get 6.92 sine of B is equivalent to 4.82 sine of 25.2. Now to find B, I have to first isolate the sine of B. So I'm going to divide by that 6.92. And if I divide by that 6.92, it cancels on this side. And I'm left with the sine of B. And I'm actually going to utilize my calculator. If I input this into my calculator, I have 4.82 sine of 25.2. And I'm going to divide it by 6.92. We're going to get sine of B to be approximately 0.297. And guys, remember, when we find angle measurements, we do inverse sine. So B would be equivalent to the inverse sine of 0.297. So let's take a look. So I do second sine, second answer, and I'm going to get B to be approximately 17.252 degrees. All right, guys. Now, the reason that we might have a different B is because when we have the ambiguous case, you have a possibility of two triangles. So a lot of times we need to look at two cases. So I would address it as case one. Okay. I would look at a case one, and then I would also look at a case two. Okay. Now in case one, we use the first B that we found. So in case one, I'm going to take that first B that I found. So I'm going to say, okay, well, case one's going to have this B. All right. And a lot of times when I work with case one and I'm looking at that B, I call it B1. And the reason I call it B1 is so I can differentiate it so that when I'm working with case two, I'm going to call it B2. And that's if we possibly have two triangles. Now, how do we find what B2 could possibly be? Well, we have to remember that sine is positive. If we look at this, we're finding the sine of a positive value, 0.297. Sine is positive in quadrant 1 and quadrant 2. So the other value that would have a sine value of 0.297 would be the supplement of B1. So in order to find B2, you would say, I need to take 180 and I need to subtract B1 from that. Well, let's take a look. You have to do 180 minus 17.252 degrees. Well, if I subtract that 180 minus 17.252, I'm going to get B2 to be equivalent to 162.748 degrees. So now we're looking at two possible cases. All right. So now let's go back up. We know our measurements. If I look at my measurements, A is 25.2 degrees. You were given one angle measurement. So now if we found another angle measurement, B, we can easily now find out what C could be. So in case one, C1 would be 180 minus the 17.252, which is B1, minus what we were given, and we were given 25.2 degrees. Okay, so if I subtract all that, I get 180 minus that 17.252 minus 25.2 degrees. I get C1 to be equivalent to 137.548 degrees. Okay, so that's an obtuse angle. That makes sense. So now we have these two angles in our triangle. Okay, so I have C1 and I should probably not make that purple so it's less confusing. I also have B1. Ooh. I also have B1. All right, guys. So I have the two angles in case one. Well, let's try to find the third angle in case two. So let's take a look at case two. Let's try to find that third angle. So in case two, to find the third angle, I would say C2 would equal 180 minus the 162, which is B2, minus the 25.2, which is A. Now, guys, what happens when you do that? You get 180 minus 162.748 minus 25.2. You get C2 to be a negative value. Is it possible to have a negative measurement in your triangle? Absolutely not. So this triangle does not exist. So in that case, case two. If case two doesn't work, we only have one triangle. So we only have one triangle as the solution. If case two worked, we would have two triangles as the solution. All right. So now we have B1 and C1. Our angle measurements. We have those two angle measurements. We have angle A, we have side length A and side length B. So all we're missing now is finding side length C. So we need to use the information we have to find it. So if I take a look at this, to find side length C, I can say I'm going to do little c over the sine of 137.548 would equal what we knew A was. Little a was 6.92, all over the sine of A, which is 25.2. So let's solve for little c. I'd cross multiply. I'd get C sine of 25.2 would equal 6.92 times the sine of 137.548. And then we would divide by that sine of 25.2. So let's put that in my calculator. I get 6.92 times the sine of 137.548 divided by the sine of 25.2. And I would get that C to be my little c, that last C, little c1 from that triangle, to be 10.97. Okay, 10.970. So that would be the third unknown of that triangle. All right, guys, I hope that helped a little with the ambiguous case. I know it is one of the more trickier problems. You have two problems attached below this video for homework 2. So your homework is the 2 area formulas from the packet, the 2 area problems, and then the 2 problems on the ambiguous case again. If you have any questions, please come to my office hours. They are from 9:15 to 10 a.m. in the morning, and then from 2 to 2:45 in the afternoon. I would really appreciate it if everybody please checks in at some point this week. So you have Monday, Tuesday, Wednesday, Thursday to check in. If you have any difficulty and you need one-on-one assistance, we can set up an appointment for Friday during the math off day if you really need any assistance. We are planning a quiz on Thursday, so if you have assistance, it would probably be better to come to me either Monday, Tuesday, or Wednesday to prepare you for the WebAssign quiz on Thursday. All right, guys, I hope you have a great day, and I will hopefully see you at office hours.